This mechanic looks simple, but there's a lot happening behind the scenes. Welcome to the first episode of Behind the Mechanic, where we reverse engineer popular game mechanics and rebuild them from scratch in Unity. Today we're recreating Mash Triple Ball's floating objects mechanic. Let's get started. Let's start with an empty scene. So first we create a sphere. I'll name it glass ball. In the game we can see the objects colliding with inner wall of the sphere, but we'll not be using colliders for that. So let's remove the sphere collider. Let's reset its position so it's at the center and scale it to 5 units. I have already created a simple glass material, so I'll just apply that to sphere. Now for the 3D objects inside the sphere, let's create a cube. Let's set its scale to about 0.5 units. For the physics-based movement of the object, let's add a rigid body component and I'll disable gravity as we don't need it. Now in the game, we see there are many of these objects spawning at once. So let's make this cube object a prefab so we can spawn multiple instances of it via code. I'll just name it item. Now we can just delete this from the scene. Since Unity doesn't have a built-in inside of sphere collider that keeps objects contained, we need to manually check if an object has gone outside of the sphere and gently pushing it back in while making it look like it bounced off the inner wall. So let's create a script for the collision behavior of the items. Let's call it item collision handler. We'll start by removing the start and update. Now let's define some properties for the collision. First we'll need a collision radius, which is basically the radius of the sphere. Let's set it to value of 2.5. Next is spread multiplier, which is the value of how much the items will spread. Let's set it to value of 0.5. We'll define a bounce strength, which is the amount of bounce after hitting the wall of the sphere. Another variable for the damping, and the last one will be smooth push. The damping value is how much velocity to keep after the bounce, and a smooth push is how strongly to push back inside. Since we'll be doing physics calculations, so we'll use fixed update instead of update. We'll be spawning all the items as a child of this sphere. So inside the fixed update, let's loop through all the rigid body as child of this sphere, and then for each rigid body, calculate a vector 3 offset from its position to the center of the sphere. This will give us the position of the item relative to the center of the sphere. To get the magnitude of the offset, we create a local float variable dist. Now we compare the distance with the radius of the sphere, that is the collision radius. And if the offset is greater, that means it has crossed the sphere boundary, so we'll be adding the bounce back forces. First we get the normal, which is basically the direction of the item from the center. Now we'll be pushing the object softly towards the inside. For that, we first calculate where the object should be inside the sphere. So we multiply the normal with the collision radius and add that to the center of the sphere. Also multiplying this with 0.98, so the target position is just slightly inside, not exactly at the boundary. Now we smoothly interpolate the item towards the target position using vector 3.lerp. We multiply time.fixedDeltaTime with smooth push to get a smooth pushback. Now higher smooth push value means a faster snapback, while a lower value will get a softer correction. This is what makes the movement feel natural. Next we add the bounce effect. For that, we calculate a reflected velocity, which will be the velocity of the item after hitting the sphere wall. Vector 3.reflect basically does all those calculations to get the reflecting velocity of the item, just like light bouncing off a mirror. We give the linear velocity of the rigid body, and the normal that we calculated defines the plane to bounce off, and multiply that with the bounce strength property that we had defined. Then we smoothly blend the velocity of the rigid body to the reflected velocity using vector 3.lerp multiplied with time.fixedDeltaTime. This avoids abrupt, unnatural changes and makes the collision feel softer. Finally, we multiply the linear velocity with the damping value and time.fixedDeltaTime like this to slowly reduce the reflecting velocity of the item. So the damping prevents the item from bouncing forever and helps create the gentle floating effect. Let's save the script and go back to Unity. We need to create one more script for the items. As in the game, we see the items always keep moving slightly like they're floating, and for that we create an item script. Let's delete the start and update. We create two variables, one to store the rigid body and another to store the force that will apply to the move the item. We'll be adding the force in the fixed update since it's physics-based. Let's use the addForce function and multiply the force with random.InsideUnitSphere to get a random direction every physics update. Let's save the script and go back to Unity. Let's go to the item prefab and add the item script to it. Give the reference to the rigid body and let's set the force strength value to 2. Let's go to the scene and add the item collision handler script to the glass ball. Now just to test the behavior, let's bring the item prefab and make it a child of the glass ball. Let's play and see, and as you can see, the cube smoothly floats and goes towards the inner wall and then cannot go beyond, which is what we want. But let's decrease the collision radius a bit. Let's set to 2. Now let's see Yes, so now it stays within the boundary and also bounces back on hitting. Let's add a few more cubes and see how it looks. Okay, so they float around and when they hit the boundary, they bounce back slightly and keep floating. Now it's time to spawn the cubes using code. So let's create a script. Let's call it item spawner. As usually, delete the start and update. Let's create a variable to store the prefab. We'll also need a reference to the sphere transfer, which will basically be the parent of all the items. And last, we'll create an item count variable that will store the number of items we want to spawn. We'll set it to 24 now. Let's spawn the items in start. We'll create a for loop till the item count and instantiate the item prefab at the position of the item parent with the random rotation. Then we'll set its parent to item parent transfer. Now let's go back to Unity and create an empty game object, reset its transform, adding the item spawner script, adding reference to the item prefab, the item parent transform, which is the glass ball, and let's press play. And as you can see, 20 cubes spawn at the center and then float around in the sphere. Now you can probably notice that at the start they quickly spread out with a lot of force due to so many colliders overlapping. And we can reduce this speed in the physics settings. So let's go to Edit, Project Settings, Physics Settings, Game Object tab. Here's a property called Default Max Penetration Velocity, which is basically the max velocity to apply when there are colliding rigid bodies. And it's set to 10, which is why they spread out so quickly. So let's just set it to a value of 1 and close this. Now let's press play and you can see they smoothly move away from each other and float around in the sphere and also collides with its inner wall. Okay, so the spawning is done, but when we see the game, you can see the items don't spawn all at once. They have a very slight delay between each spawn, and the items also moves from the center to random points inside the sphere. There's also a very quick scale-up animation, so it looks like the item starts from 0 scale and then quickly scales up to the final size, which makes this item spawn animation visually appealing. So let's try to do that. Let's go to the item spawner script. For the delay between each item, we can use a coroutine. So let's create an item rotor, spawn routine, and let's move the code inside the start to here and call the code routine in start. For the delay, it should be a very small value, so let's keep it about 0.01 seconds. Let's go back to Unity and press play. And now there's a very small delay between each cube spawning. Now to move the cubes to random positions inside the sphere, we need a reference to the item collision handler and its properties, collision radius and spread multiplier. So we'll replace the transform with item collision handler data type and rename the variable 2 as item collision handler. We've got an error, so here we need the transform, and now it's fixed. Now we calculate that random position, so we use random.InsideUnitSphere and multiply that with the item collision handler collision radius. But that variable is private, so we need to make it public. Let's go to the item collision handler script, and we need to make both the collision radius and the spread multiplier as public. Let's just add a public getter to both of them. Now when we go back to the item spawner script, we can access the collision radius and we also multiply with the spread multiplier. So this will give us that random position inside the sphere. Now we can smoothly move the item towards the final position. For that I'm using doTween, which is a very useful tweening library. It is a function called doMove that does exactly what we need, that is smoothly move to a target position, and we can give a duration of the animation. Let's set it to 0.2 seconds. Now let's go back to Unity and play. We need to again add the reference to the item collision handler as we change the variable data type and name. Now let's play. And as you can see, the cube smoothly move from the center to random positions. The last thing we'll add is a scale up from 0 animation. So let's go back to the script and we'll set the scale of the item to vector 3.0. But before that, we need to store its original or final scale. Let's store that in a local variable. Now we can just use another useful doTween function, doScale, to smoothly scale the item to the final scale. Let's give the duration 0.3 seconds. Let's go back to Unity and press play. And we can play around with these durations until we get the desired animation. So I've gone ahead and created some item prefabs to use instead of the cubes. As you can see here, this is the base prefab which only has the rigid body and the item component. And I created multiple prefab variants from that. I just added different models as a child and added a box collider to that. I created a bottle, burger, donut and all these different items. Now let's go to the item spawner script again, and instead of the single prefab, we'll replace that with an array of game object references to store the item prefabs. And in the spawn routine, just spawn a random item from that array. Let's go back to Unity and add the references to all the items that I created. Now let's press play. And as you can see, the items are randomly spawned. We change the spawn count to let's say 50 and see. Let's increase that to 100 items and see. And as you can see, it looks just like in the game. And obviously we can play with different values for the spawner as well as the force on the items to make it match exactly. I'll just leave it like this. The last thing we'll do is make the glass ball rotate with tap and drag, just like in the game. Let's create a script and call it sphere rotator. Let's open it, delete the start and update. Let's create some serialized properties for rotation speed. Let's set it to 10. This is basically the drag sensitivity. Inertia damping, and let's set it to 4. So this is basically once we stop dragging, the sphere will not instantly stop rotation, but it will slowly come to a stop. A higher value means it will stop faster. Let's have a max speed about 500, which is in degrees per second. We need some private variables to show the last pointer position and the angular velocity of the rotating sphere. There will be two bools, one for drag started, another is dragging. We'll take the input in the update. Let's create a local variable drag delta and set it to vector 2.0. If we press the mouse button down, then set drag started to true and set the last pointer position to the mouse position. If we lift the mouse click, set drag started to false. If the drag started is true and we have not lifted the mouse, the new mouse position will be the current mouse position and the drag delta will be the new position minus the last pointer position. And last pointer position will be new position. Now the ease dragging will only be true if either the drag delta x or the drag delta y is greater than this threshold value of 5. Otherwise, the sphere will rotate even with tiny pointer movements, which we obviously don't want. We'll have a very similar approach for the touch input as well. Now we'll actually rotate the sphere. Let's convert the drag to rotation in wall space. We'll use the rotation speed value here and multiply that with time to delta time. Now we'll just calculate the delta rotation, that is a change in the rotation using the x and y rotation values, and add that to the current rotation of the sphere. Let's also calculate the angular velocity and also clamp it to the max speed. And if the drag has ended, then we'll add the inertia. So if the angular velocity is more than this, calculate the delta rotation from the angular velocity and multiply that to the current rotation of the sphere. And the angular velocity will smoothly interpolate to vector 3.0 and use the inertia damping value here. Let's save the script and go back to Unity and add the sphere rotator script to the glass ball. Let's press play. The items are spawning, and when we drag the mouse, the sphere rotates just like the game. After adding the background and everything, the final result looks like this. That's it for today's episode of Behind the Mechanic. If there's another game mechanic you'd like me to reverse engineer, leave it in the comments and I'll see you in the next one.